Now, in this lecture, we will find out the radius of the circle. In the drawing, we have this blue circle, and inside the circle, we have quadrilateral ABCD. We know that side AB of quadrilateral ABCD equals to 3 units, so we will define side AB of quadrilateral ABCD as A. Therefore, A will be equal to 3 units. And we also know that side BC of quadrilateral ABCD equals to 4 units. So we will define side BC as B, and B will be equal to 4 units according to what is given us in the question. And we also know that side CD of quadrilateral ABCD equals to 5 units. So we will define side CD as C, and C will be equal to 5 units. And we also know that side AD, this side of quadrilateral ABCD, equals to 6 units. So we will define side AD as D, and D will be equal to 6 units. Okay, and we want to find out the radius of this blue circle. So I will present to you 3 new walls, and we will implement those 3 new walls in our drawing. So wall number 1 is that the area of quadrilateral ABCD that it is inscribed by a circle equals to actually this is the sign of area of, it means the area of quadrilateral ABCD equals to the root of S minus A times S minus B times S minus C times S minus D. Actually, A, B, C, and D are the lengths of quadrilateral ABCD sides, and S S equals to A plus B plus C plus D over 2. So actually, if we have quadrilateral ABCD, if we have quadrilateral ABCD, that could be any quadrilateral. So this quadrilateral A, B, C, D could be any quadrilateral, and we know that side AB, this side of quadrilateral ABCD equals to A units in its size we also know that side BC of quadrilateral ABCD equals to B units in its size, side CD equals to C units in its size, and side AD equals to D units in its size. And so you can see that quadrilateral ABCD is inscribed by this blue circle. Therefore, according to rule number 1, the area of this red quadrilateral ABCD will be equal to the root of S minus A times S minus B times S minus C times S minus D so actually A, B, C and D are the lengths of quadrilateral A, B, C, D. AB equals to A units, this is to say the length of side AB of quadrilateral ABCD equals to A units, and the length of side BC is B units, the length of side CD is C units, and the length of side AD of quadrilateral ABCD equals to D units, and S equals to A plus B plus C plus D over 2. Okay, so if you have quadrilateral that it is inscribed by a circle like in this drawing, then the area of that quadrilateral can be calculated according to this formula, and in this formula A, B, C and D are the lengths of quadrilateral ABCD, and S equals to A plus B plus C plus D over 2. Okay, so that is actually rule number 1. And we also have rule number 2. Rule number 2 states that if quadrilateral ABCD is inscribed by a circle, then the product of its diagonals equals to the sum of the products of its opposite sides. So I will read rule number 2 again. Rule number 2 states that if quadrilateral ABCD is inscribed by a circle, then the product of its diagonals equals to the sum of the products of its opposite sides. So, what is the meaning of rule number 2? The meaning of rule number 2 is that if we have this circle and inside this circle we have a quadrilateral ABCD that is inscribed by this circle, I will repeat again, quadrilateral ABCD is inscribed by this circle, and we also know that side AB of this quadrilateral equals to A units in its size, side BC of quadrilateral ABCD equals to B units in its size, side CD equals to C units in its size, and side AD equals to D units in its size. And we also know that BD, diagonal BD of quadrilateral ABCD, the size of diagonal BD of quadrilateral ABCD is X, that is to say it equals to X units in its size, diagonal BD equals to X units in its size. And we also know that the second diagonal AC equals to Y units in its size. Then, according to rule number 2, the product of its diagonals, that is to say X times Y, equals to the sum of the products of its opposite sides. So actually quadrilateral ABCD has two pairs of opposite sides. Side AD is opposite to side BC, and side AB is opposite to side CD. So the first product of its opposite sides, again AD is opposite to side BC, and the first product of its opposite sides, it is actually B times D. That is the first product of its opposite sides. And the second product of his opposite sides is, again, AB is opposite to CD. Therefore, the second product of his opposite sides is A times C. And the sum of the products of his opposite sides, it is actually BD plus AC. And according to rule number 2, the product of its diagonals, that is to say X times Y, equals to the sum of the products of its opposite sides. That is to say it equals to BD plus AC. Okay, so I'll repeat again. Rule number 2 states that if quadrilateral ABCD is inscribed by a circle, so we have this quadrilateral ABCD, that it is inscribed by this blue circle. Therefore, according to rule number 2, the product of its diagonals, that is to say X times Y, it is the product of its diagonals, equals to the sum of the products of its opposite sides. And the sum of the products of his opposite sides is BD plus AC. So X times Y, that is the product of its diagonals, equals to the sum of the products of its opposite sides, that is actually BD plus AC, or XY equals to BD plus AC. That is the meaning of rule number 2. So if you have quadrilateral that it is inscribed by a circle, then the product of its diagonals, in this case is X times Y, will be equal to the sum of the products of its opposite sides, will be equal to BD plus AC. That is the sum of the products of its opposite sides. Okay, That is actually rule number 2. And we also have rule number 3. Rule number 3 states that if triangle ABC is inscribed by a circle, then the radius of that circle equals to the product of triangle ABC sides over 4 times the area of triangle ABC. So I will read rule number 2 again. Rule number 3, I will read rule number 3 again. Rule number 3 says that if triangle ABC is inscribed by a circle, then the radius of that circle equals to the product of triangle ABC sides over 4 times the area of triangle ABC. So what is the meaning of rule number 3? The meaning of rule number 3 is that if we have this circle and triangle ABC is inscribed in this circle. So we have triangle ABC that it is inscribed by this circle, triangle ABC is inscribed by this blue circle, and we also know that side AB of triangle ABC equals to A units in its size, side BC of triangle ABC equals to B units in its size, and side AC of triangle ABC equals to C units in its size. Then, according to rule number 3, the radius of that circle that blocks triangle ABC equals to the product of triangle ABC sides. So the radius of this blue circle equals to the product of triangle ABC sides. That is to say, it will be equal to A times B times C, because A times B times C is the product of triangle ABC sides over 4 times the area of triangle ABC, over 4 times the area of triangle ABC. Okay, so according to rule number 3, if you have triangle ABC that it is inscribed by this circle, as in the drawing we have triangle ABC that it is inscribed by this blue circle, then the radius of that circle that blocks triangle ABC will be equal to the product of triangle ABC sides, and the product of triangle ABC sides is A times B times C over 4 times the area of triangle ABC over 4 times the area of triangle ABC. Okay, so actually if you have triangle ABC that it is inscribed by a circle, you can find out the radius of that circle that blocks triangle ABC. That could be any triangle. According to this formula, the radius of that circle will be equal to ABC, that is the product of the triangle's sides, over 4 times the area of the triangle, over 4 times the area of triangle ABC in our example. Okay, that is actually rule number 3, and we can implement all 3 rules in our drawing. So according to rule number 1, the area of this red quadrilateral ABCD that it is inscribed by this blue circle equals to the root of S minus A times S minus B times S minus C times S minus D, when A, B, C, and D are the lengths of quadrilateral ABC sides. In our case, S equals to 3 units, B equals to 4 units, C equals to 5 units, and D equals to 6 units. And S equals to A plus B plus C plus D over 2. Okay, that is the implementation of rule number 1 in our drawing. We can also implement rule number 2 in our drawing. According to rule number 2, if we have quadrilateral ABCD that is inscribed by a circle, by this blue circle, then the product of its diagonals, that is to say, quadrilateral ABCD has 2 diagonals. The first diagonal is diagonal AC, and we define diagonal AC as x, that is to say, diagonal AC equals to x units in its size. And we also have the second diagonal, diagonal BD, and the diagonal BD will be defined as y, that is to say, BD equals to 1 unit in its size. So according to rule number 2, the product of quadrilateral ABC the diagonals x times y equals to the sum of the products of its opposite sides. Here, quadrilateral ABCD has two pairs of opposite sides. Side BC is opposite to side BD, and the product of these first opposite sides, it is actually B times D. And we also know that side AB is opposite to side CD, and the product of these two opposite sides, it is actually A times C. And according to rule number 2, the product of its diagonals, that is to say x times y, equals to the sum of the products of its opposite sides, equals to BD plus AC. So according to rule number 2, if we implement rule number 2 in our drawing, we will get that x times y equals to BD plus AC. Okay? And we'll also implement rule number 3 in our drawing. According to rule number 3, if we have this triangle ABC that is inscribed by this blue circle, then the radius of this blue circle, that is to say capital R, will be equal to the product of triangle ABC sides, that is to say it will be equal to A times B times X over 4 times the area of triangle ABC, over 4 times the area of triangle ABC. So I will repeat again. According to rule number 3, if we have triangle, in our example, triangle ABC, this triangle is inscribed by this blue circle. Therefore, according to rule number 3, the radius of this blue circle will be equal to the product of triangle ABC sides, and the product of triangle ABC sides is A times B times X over 4 times the area of triangle ABC. Okay? Over 4 times the area of triangle ABC. So the radius of the circle that blocks triangle ABC will be equal to the product of triangle ABC sides, that is to say A times B times X over 4 times the area of triangle ABC. That is according to rule number 3. So here we will multiply equation number 3 by the area of triangle ABC, and we will get that R times the area of triangle ABC equals to ABX over 4. Here we will divide equation number 3 by R, and we will get the area of triangle ABC. Okay, so according to equation number 3, the area of triangle ABC will be equal to ABX over 4R. So we actually found out the area of triangle ABC. According to equation number 3, it equals to ABX over 4R. Okay? So in the next step we will focus on triangle ADC. Actually, triangle ADC, this triangle is inscribed by this blue circle. Therefore, according to rule number 3, the radius of this blue circle that blocks triangle ADC will be equal to the product of triangle ADC sides, that is to say C times D times X, over 4 times the area of triangle ADC. So I repeat again, if you focus on this triangle ADC, actually this triangle ADC is inscribed by this blue circle. Therefore, according to rule number 3, whenever you have triangle that it is inscribed by a circle, then the radius of that circle that blocks the triangle will be equal to the product of triangles sides. That is to say, it will be equal to C times D times X over 4 times the area of the triangle that is inscribed by that circle, over 4 times the area of triangle ADC. So here we will multiply equation number 4 by the area of triangle ADC, and we will get that R times the area of triangle ADC equals to CDX over 4. So here we divide the equation number 4 by R in order to get the area of triangle ADC, and we will get that the area of triangle ADC, according to equation number 4, will be equal to CDX over 4R. So we actually found out the areas of triangles ADC and the area of triangle ABC also. But as you can see from the drawing, if we combine triangle ABC with triangle ADC, we will get the quadrilateral ABCD, because quadrilateral ABCD consists of those two triangles, triangle ABC and triangle ADC. Therefore, the area of quadrilateral ABCD will be equal to the area of triangle ABC plus the area of triangle ADC. Okay, so I write it down. The area of quadrilateral ABCD, according to equation number 1, will be equal to the area of triangle ABC plus the area of triangle ADC, because of the fact that quadrilateral ABCD consists of those two triangles. Okay? So the area of quadrilateral ABCD will be equal to the area of triangle ABC. That is actually, we have already found out that the area of triangle ABC equals to bx over 4r plus the area of triangle ADC, and we have already found out that the area of triangle ADC equals to CDX over 4r. So here we will take x over 4r as a common factor of those two expressions, and we will get that the area of quadrilateral ABCD, according to equation number 1, equals to x over 4r is a common factor of those two expressions, and what is left in the bracket, inside the brackets, after we took x over 4r as a common factor of those two expressions, here what is left is AB, and what is left here is CD. So in total we got that the area of quadrilateral ABCD, according to equation number 1, equals to x over 4r times AB plus CD. Okay, so in the next step we will focus on this triangle BDC. Actually, this triangle BDC is described by this blue circle. Therefore, according to rule number 3, the radius of this blue circle that blocks triangle BDC will be equal to the product of triangle BDC sides, that is to say, it will be equal to B times C times Y over 4 times the area of this triangle BDC. So I will repeat again, this triangle BDC is inscribed by this blue circle. Therefore, according to rule number 3, the radius of this blue circle that blocks triangle BDC will be equal to the product of triangle BDC sides, that is to say, it will be equal to B times C times Y over 4 times the area of triangle BDC. That is true according to rule number 3. Here we will multiply equation number 5 with the area of triangle BDC, and we will get that R times the area of triangle BDC equals to BCY over 4. We will divide equation number 1 by R, and we will divide equation number 5, this equation, by R, and we will get that the area of triangle BDC, according to equation number 5, equals to BCY over 4R. So we actually found out the area of triangle BDC is equals to BCY over 4R. In the next step, we will focus on this triangle ABD. Actually, this triangle, triangle ABD, is inscribed by this blue circle. Therefore, according to rule number 3, the radius of this blue circle that blocks triangle ABD will be equal to the product of triangle ABD sides, that is to say, it will be equal to A times D times Y, over 4 times the area of this triangle, triangle ABD. Again, it is true according to rule number 3. So I repeat again, this triangle, triangle ABD, is inscribed by this blue circle. Therefore, according to rule number 3, the radius of this blue circle that blocks triangle ABD will be equal to the product of triangle ABD sides, that is to say, it will be equal to A times D times Y, A times D times Y over 4 times the area of triangle ABD. Here we will multiply equation number 6 by the area of triangle ABD, and we will get that R times the area of triangle ABD equals to ADY over 4. Here we will divide the equation number 6 by R, and we will get that the area of triangle ABD, according to equation number 6, will be equal to ADY over 4R. I repeat again, the area of triangle ABD will be equal to ADY over 4R. But we have already found out that the area of triangle BDC, according to equation number 5, equals to BCY over 4R. But as you can see from the drawing, if we combine triangle BDC with triangle ABD, we get quadrilateral ABD. Again, if we combine triangle BDC with triangle ABD, we'll get the quadrilateral ABCD. Therefore, actually the area of quadrilateral ABCD, according to equation number 2, will be equal to the area of triangle BDC plus the area of this triangle, triangle ABD. I repeat again, quadrilateral ABCD consists of two triangles, exactly two triangles, triangle BDC and triangle ABD. Therefore, the area of quadrilateral ABCD will be equal to the area of triangle BDC plus the area of triangle ABD. Okay, if we combine those two triangles, we will get the triangle the quadrilateral ABCD. Therefore, the area of quadrilateral ABCD will be equal to the area of triangle BDC plus the area of triangle ABD. Okay, so the area of quadrilateral ABCD equals to the area of triangle BDC, but we have already found out that the area of triangle BDC equals to BCY over 4R plus the area of triangle ABD, but we already found out that the area of triangle ABD equals to ADY over 4R. Okay. So the area of quadrilateral ABCD equals to BCY over 4R plus ADY over 4R. Here we take a common factor of y over 4R out of this expressions, and we will get that the area of quadrilateral ABCD according to equation number 2 equals to y over 4R is the common factor of these two expressions. And what is left inside the brackets here, what is left is BC, and what is left here is AD. So we actually found out that the area of quadrilateral ABCD according to equation number 2 equals to y over 4R times BC plus AD. Okay, but we have already found out that the area of quadrilateral ABCD according to equation number 1 equals to x over 4R times AB plus CD. According to equation number 1, the area of quadrilateral ABCD equals to x over 4R AB plus CD. So here we will multiply equation number 1 by equation number 2, and we will get that the area of quadrilateral ABCD squared, this will be equation number 3, the area of quadrilateral ABCD squared equals to x times y over 4R squared times BC plus AD times AB plus CD. So we actually multiplied equation number 1 by equation number 2, and we got that the area of quadrilateral ABCD squared equals to xy times BC plus AD times AB plus CD over 4R squared. So here we take a root out of this equality, and we will get that the area of quadrilateral ABCD according to equation number 3 equals to the root of x times y times BC plus AD times AB plus CD and the root of 4R squared is 4R because the root cancels the square, and what is left is 4R. So here we'll multiply equation number 3 by R, and we will get that R times the area of quadrilateral ABCD equals to the root of x times y, BC plus AD, AB times AB plus CD. All divided by 4. So here we divide the equation number 3 by the area of quadrilateral ABCD, and we will get the radius that we are looking for. According to equation number 3, the radius that we are looking for equals to the root of x times y times BC plus AD times AB plus CD over 4 times the area of quadrilateral ABCD. Okay, this is the expression that we get after we divided the equation number 3 by the area of quadrilateral ABCD. So here we have x times y, but we know that according to rule number 2, x times y equals to AC plus BD, according to rule number 2. Okay, so we can substitute xy in equation number 3, this equation, by AC plus BD, because xy equals to AC plus BD. So we'll do it now. We'll substitute xy by AC plus BD. And we'll get that the radius that we are looking for equals to, so xy, we substitute xy by AC plus BD. They are equal according to rule number 2. Times BC plus AD times AB plus CD over 4 times the area of quadrilateral ABCD. So actually we substituted xy by AC plus BD, and we got this equation number 3. So here the only thing that is left to find is to find the area of quadrilateral ABCD, and then we will have all the values of all the variables here. So we already found out the area of quadrilateral ABCD, but I will repeat on the same process. The area of quadrilateral ABCD, according to rule number 1, equals to the root of S minus A times S minus B times S minus C times S minus D. When A, B, C, and D are the lengths of the quadrilateral ABCD sides, and S equals to A plus b plus c plus d over 2. Okay, we've already found out these expressions, but I repeated on this again. So here we know that A equals to 3 units, B equals to 4 units, C equals to 5 units, and D equals to 6 units. Therefore, S will be equal to A is 3, B is 4, C is 5, and D is 6, all divided by 2, so 3 plus 4 is 7, 7 plus 5 is 12, and 12 plus 6 is 18, and 18 over 2 is 9, so we found out that S equals to 9. So we will substitute S by 9 in this equality, and we will get that the area of quadrilateral ABCD according to this equality equals to the root of S minus A. S is 9, A is 3, so it is 9 minus 3. S minus B, S is 9, B is 4, so it is 9 minus 4. S minus C, S is 9, C is 5, so it is 9 minus 5. And we have also S minus D, S is 9, D is 6, so it is 9 minus 6. So in total we got that the area of quadrilateral ABCD equals to the root of this expression. So here, so the area of quadrilateral ABCD according to this equality will be equal to the root of 9 minus 3 is 6, 9 minus 4 is 5, 9 minus 5 is 4, and 9 minus 6 is 3. So the area of quadrilateral ABCD will be equal to the root of 6 times 5 is 30, 30 times 4 is 120, and 120 times 3 is 360. So we found out that the area of quadrilateral ABCD equals to the root of 360, or the root of 360 square units. Okay, so now we can substitute the area of quadrilateral ABCD here by the root of 360 that we found here. So we'll do it now, and we will get that the radius of the circle that we are looking for, according to equation number 3, will be equal to the root of So here we have equation number 3. I'll repeat again. We will substitute the area of quadrilateral ABCD by root 360 that we found in this equation number 3, and we will get that R equals to the root of AC plus BD times BC plus AD times AB times AB plus CD over the area of quadrilateral ABCD. We have already found out that the area of quadrilateral ABCD equals to the root of 360, and we must divide all by 4. Okay, we divide it by 4. So actually we have here all the variables inside this equality equation number 4 are known. I will write the values of all the variables that are inside this equation number 3. We actually know that A equals to 3 units, B equals to 4 units, C equals to 5 units, and D equals to 6 units. So we will get that the values that we are looking for, according to this equation number 3, equals to the root of AC. A is 3, C is 5, so 3 times 5 is 15, plus BD. B is 4, D is 6, and 4 times 6 is 24, times BC. B is 4, C is 5, so 4 times 5 is 20, plus AD. A is 3, D is 6, so 3 times 6 is 18, times AB. A is 3, B is 4, so 3 times 4 is 12, plus CD. C is 5, D is 6, so 5 times 6 is 30, and all divided by 360. So according to equation number 6, the radius that we are looking for equals to this expression. So here the radius of the circle that we are looking for will be equal to the root of 15 plus 24 is 39, 20 plus 18 is 38, and 12 plus 30 is 42, over 360. So the radius equals to the root of this expression. Actually, the radius will be equal to the root of 39 times 38 times 42 over 360 equals to 172.9, and we must divide all by 4. So it is divided by 4. So we actually found out that the radius of this circle equals to the root of 172.9 over 4 units, or in terms of numbers, the radius equals to 3.287 units. I will repeat again, the radius of this circle equals to either the root of 172.9 over 4 units, or in terms of numbers, the radius of this circle equals to 3.287 units. And that is the answer to the question. So now I will summarize the lecture. Actually, we wanted to find out the radius of this circle. This circle blocks quadrilateral ABCD, or quadrilateral ABCD is inscribed by this circle, and we know that side AB is 3 units, so we define side AB as A equals to 3 units, side BC of quadrilateral ABCD equals to 4 units, so we defined side BC as B, so therefore B will be equal to 4 units, side CD equals to 5 units, so we define side CD as C, so C will be equal to 5 units, and side AD of quadrilateral ABCD equals to 6 units, so we define side AD as D, and D will be equal to 6 units. And we want to find out the radius of this circle. So I presented to you 3 new rules, and we implemented the 3 new rules in our drawing. Actually, the first rule is related to the area of quadrilateral ABCD that is inscribed by a circle. According to rule number 1, the area of quadrilateral ABCD that is inscribed by a circle equals to the area. Rule number 1 states that the area of quadrilateral ABCD, the area of this quadrilateral ABCD, that it is inscribed by a circle. This quadrilateral ABCD in the red color is inscribed by this blue circle. So the area equals to, this is the sign of the area, it means the area of quadrilateral ABCD, it equals to the root of S minus A times S minus B times S minus C times S minus D, when A, B, C, and D are the lengths of the 4 sides of quadrilateral ABCD, and S equals to A plus B plus C plus D. So whenever you have quadrilateral that is inscribed by a circle, then the area of that quadrilateral can be calculated according to this formula, and that is actually rule number 1. And we also have rule number 2, Rule number 2 states that if quadrilateral ABCD is inscribed by a circle, then the product of its diagonals equals to the sum of the products of its opposite sides. So what is the meaning of rule number 2? The meaning of rule number 2 is that if you have this quadrilateral ABCD, if quadrilateral ABCD is inscribed by a circle like in this drawing, quadrilateral ABCD in the red color is inscribed by this blue circle, then according to rule number 2, the product of its diagonals, quadrilateral ABCD has two diagonals. Diagonal AC equals to y units in its size, and diagonal BD equals to x units in its size, and the product of its diagonals, it is actually x times y, equals to, according to rule number 2, equals to the sum of the products of its opposite sides. And the sum of the products of its opposite sides is actually quadrilateral ABCD has two pairs of opposite sides. The first pair of opposite sides is side AB is opposite to side CD, and side AB equals to A units in its size, and side AC equals to C units, side CD equals to C units in its size, and the product of those two opposite sides, it is actually A times C. And the product of the second opposite side, side AD, is opposite to side BC, and the product of those two opposite sides is actually B times D. And according to rule number 2, the product of its diagonals, that is to say x times y, equals to the sum of the products of its opposite sides. And the sum of the products of its opposite sides, it is actually BD plus AC. So in total, x times y, the product of its diagonals, equals to the sum of the products of its opposite sides, equals to BD plus AC. So whenever you have a quadrilateral ABCD that is inscribed by a circle, then the product of the quadrilateral ABCD diagonals, that is x times y, will be equal to the sum of the products of its opposite sides, will be equal to BD plus AC. Because actually this quadrilateral ABCD could be any quadrilateral. Okay? So if you have quadrilateral ABCD like this quadrilateral, that could be any quadrilateral, then the products of its diagonals, that is to say x times y, will be equal to the sum of the products of its opposite sides, will be equal to BD plus AC. Okay, but it is true only in quadrilateral that are inscribed by a circle. Only if a quadrilateral is inscribed by a circle, then this rule is true, that x times y equals to BD plus AC. Okay, actually that is rule number 2, and we also have rule number 3. According to rule number 3, if triangle ABC is inscribed by a circle, then the radius of that circle equals to the product of triangle ABC sides over 4 times the area of triangle ABC. So we are talking about this reality that we have triangle that is inscribed by a circle, and it is true only for triangles that are inscribed by a circle like in this drawing. So if we have triangle that is inscribed by a circle like in this drawing, then the radius of that circle that blocks the triangle ABC, that could be any triangle, will be equal to the product of triangle ABC sides, and the product of triangle ABC sides, it is actually A times B times C over 4 times the area of triangle ABC. Okay, so the radius of the circle that blocks the triangle will be equal to the product of triangle ABC sides, that is to say, will be equal to A times B times C over 4 times the area of triangle ABC over 4 times the area of triangle ABC. Okay, so whenever you have a triangle that is inscribed by a circle, like in this drawing, then you can find out the radius of this of that circle that blocks the triangle. According to this formula, the radius will be equal to the product of the triangle's sides over 4 times the area of the triangles. Okay, in this case it is A times B times C over 4 times the area of triangle ABC. So actually that is rule number 3. We actually implemented all the 3 rules in our drawing. So the area of this quadrilateral ABCD, according to rule number 1, the area of triangle ABC will be equal to the root of S times A times S minus B times S minus C times S minus D, when A, B, C, and D are the lengths of this quadrilateral. In this case is 3, 4, 5, and 6, and S equals to A plus B plus C plus D over 2. That is rule number 1, and we also have rule number 2. Rule number 2 is, if you have a quadrilateral ABCD that is inscribed by a circle, like in this drawing, then the product of its diagonals, that is to say x times y, will be equal to the sum of the products of its opposite sides, will be equal to BD plus AC. That is number 2, that xy will be equal to BC plus x times y will be equal to BD plus AC. And we have also rule number 3, if we relate to triangle ABC is inscribed by this blue circle. Therefore, according to rule number 3, the radius of this circle that blocks triangle ABC will be equal to the product of triangle ABC sides, that is to say, it will be equal to A times B times X. It will be equal to A times B times X over 4 times the area of triangle ABC. That is true according to rule number 3. We multiplied equation number 3 by the area of triangle ABC, and we got that the radius times the area of triangle ABC equals to ABX over 4. Then we divided equation number 3 by R, the radius, and we got that the radius, the area of triangle ABC equals to ABX over 4R. Then we focused on triangle ADC, triangle ADC, this triangle is inscribed by this blue circle. Therefore, according to rule number 3, the radius of this circle that blocks triangle ADC will be equal to the product of triangle ADC sides, that is to say, it will be equal to C times D times X, C times D times X over 4 times the area of triangle ADC. We multiplied equation number 4 by the area of triangle ADC, and we got that R times the area of triangle ADC equals to CDX over 4. Here we divided equation number 4 by R, and we got that the area of triangle ADC equals to CDX over 4R. But we know that the area of, if we combine triangle ABC with triangle ADC, we will get the quadrilateral ABCD. Therefore, the area of quadrilateral ABCD will be equal to the area of triangle ABC plus the area of triangle ADC. Okay, the area of triangle ABCD will be equal to the area of quadrilateral ABCD will be equal to the area of triangle ABC plus the area of triangle ADC. But we have already found out that the area of triangle ABC equals to ABX over 4R, and the area of triangle ADC equals to CDX over 4R. Okay, so we got this expression, and then we took x over 4r is a common factor, and we got that the area of quadrilateral ABC according to equation number 1 equals to x over 4r times AB plus CD. Then we focused on triangle BDC. This triangle BDC is inscribed by this blue circle. Therefore, according to equation to rule number 1, the radius of this circle that blocks triangle BDC will be equal to the product of triangle BDC sides, that is to say, will be equal to B times C times Y. It will be equal to B times C times Y over 4 times the area of triangle BDC. This is 2 according to rule number 3. We multiply the equation number 5 by the area of triangle BDC, and we got that R times the area of triangle BDC equals to BCY over 4. Here we divided the equation number 5 by R, and we got that the area of triangle BDC equals to BCY over 4R. Then we focus on triangle ABD. This triangle ABD is inscribed by this blue circle. Therefore, according to rule number 3, the radius of this circle that blocks triangle ABD will be equal to the product of triangles ABC sides. That is to say, it will be equal to A times D times Y. A times D times Y over 4 times the area of triangle ABD. Here we multiply the equation number 6 by the area of triangle ABD, and we got that R times the area of triangle ABD equals to ABY over 4. Here we divided equation number 6 by R, and we got that the area of triangle ABD equals to ADY over 4R. And we have already found out that the area of triangle BDC equals to BCY over 4R. And actually, the area of triangle ABD plus the area of triangle BDC is equal to the area of quadrilateral ABCD. Okay? The area of triangle BDC plus the area of triangle ABD equals to the area of quadrilateral ABCD. But we have already, okay? And here we have already found out that the area of triangle BDC equals to BCY over 4R, and the area of triangle ABD equals to ADY over 4R. We took a common factor of y over 4 out of these expressions, and we got that the area of quadrilateral ABCD according to equation number 2 equals to y over 4R, and inside the brackets we will have BC times AB. But we have already found out that the area of triangle ABCD, the area of quadrilateral ABCD according to equation number 1 equals to x over 4R times AB plus CD. So we have two different expressions for the area of quadrilateral ABCD. We multiplied the equation number 1 by equation number 2, and we got that the area of quadrilateral ABCD squared equals to this expression. Then we took a root out of this expression, and we got that the area of quadrilateral ABCD equals to the root of the numerator, and the root of 4R squared is 4R. Here we multiply the equation number 3 by R, and we got that R times the area of quadrilateral ABCD equals to the root of this expression over 4. We divided equation number 3 by the area of quadrilateral ABCD, and we got that the radius that we are looking for equals to this expression. But we know that according to rule number 2, x times y equals to BD plus AC, so we can substitute x times y in this equation number 4 by AC plus BD. So, okay, again, according to rule number 2, xy equals to AC plus BD, so we substituted xy in equation number 3 by AC plus BD, and we got this expression. And then we calculated the area of quadrilateral ABCD according to rule number 1, and S equals to A plus B plus C plus D over 2. Therefore, S equals to 9 units. And so we can substitute S in this equality by 9, because S equals to 9. So we substituted S by 9. And we have all the values of A, B, C, and D. We got this equality for the area of quadrilateral A, B, C, D. So we found out that the area of quadrilateral ABCD equals to this expression, and this expression equals to the root of 360. So we found out that the area of quadrilateral ABCD equals to the root of 360. So actually we can substitute the area of triangle ABC and the area of quadrilateral ABCD by the root of 360 in equation number 3. In this equation, we substitute the area of quadrilateral ABCD by the root of 360. So we substituted it by the root of 360, and we got this expression for the radius of the circle. We know all the values A, B, C, and D. So the only thing that is left to do is to put the data inside this equation number 3. And we got this, we put the data inside equation number 3, and we got that the radius of the circle that we are looking for equals to either the root of 172.9 over 4 units, or in terms of numbers, the radius of the circle equals to 3.287 units. I will repeat again. The radius of this circle equals to either to the root of 172.9 over 4 units, or in terms of numbers, the radius of this circle equals to 3.287 units. Okay? Thank you very much.